The history of the atomic model. Today, we're looking at some history of the atomic model. But first, don't forget to subscribe to the History channel and drop by the comments to let us know which other high-profile video you'd like to hear about next. So let's start. The concept of the atom has evolved over centuries. From ancient philosophical ideas to modern scientific theories, the atomic model has undergone significant transformations. This transcript covers the key milestones in the history of atomic theory. 1. Early philosophical concepts. Ancient Greece, 5th century BCE. The earliest ideas about atoms come from ancient Greek philosophers. Democritus and Leucippus proposed that matter was composed of small, indivisible particles called atomos, meaning uncuttable. They believed that everything in the universe was made of these atoms, which varied in size and shape, but they lacked experimental evidence to support this theory. Aristotle's rejection, 4th century BCE. The Greek philosopher Aristotle rejected Democritus's atomic theory, believing that matter was continuous and composed of 4 elements: earth, air, fire, and water. This idea prevailed for centuries, slowing the progress of atomic theory. 2. The revival of atomic theory. John Dalton, 1803. In the early 19th century, British scientist John Dalton revived the idea of atoms through his atomic theory. Dalton proposed that matter was made up of small, indivisible atoms, each element having its own type of atom. He introduced the idea that chemical reactions involved the rearrangement of these atoms. Dalton's model viewed the atom as a solid sphere, much like a billiard ball. His work was the first to link atoms to measurable chemical processes. 3. Discovery of the electron and the plum pudding model. J.J. Thomson, 1897. The next breakthrough came from J.J. Thomson, who discovered the electron while experimenting with cathode rays. He found that atoms were not indivisible, after all, but contained negatively charged particles. This led to the development of the plum pudding model, where the atom was thought to be a positive sphere, like pudding, with electrons scattered within it, much like raisins in a pudding. 4. Rutherford's nuclear model. Ernest Rutherford, 1911. In a famous experiment involving the scattering of alpha particles, Ernest Rutherford discovered that the atom had a small, dense, positively charged nucleus. Most of the atom's mass was concentrated in this nucleus, with electrons orbiting around it. Rutherford's model, often called the nuclear model, suggested that atoms were mostly empty space, with a tiny central nucleus. 5. Bohr's planetary model. Niels Bohr, 1913. Building on Rutherford's model, Danish physicist Niels Bohr proposed that electrons orbit the nucleus in specific fixed orbits, much like planets around the Sun. According to Bohr's model, electrons can jump between these orbits, but only by absorbing or emitting energy in discrete amounts, known as quanta. This model successfully explained the spectral lines of hydrogen and introduced the concept of quantized energy levels. 6th. Quantum mechanical model. Erwin Schrödinger and Werner Heisenberg, 1926. By the 1920s, the limitations of Bohr's model became apparent, leading to the development of the quantum mechanical model. Austrian physicist Erwin Schrödinger introduced a mathematical model describing electrons as wave-like entities, and Werner Heisenberg formulated the uncertainty principle, which stated that it is impossible to know both the position and momentum of an electron simultaneously. In this model, electrons do not follow fixed orbits, but exist in probability clouds or orbitals around the nucleus. 7. Discovery of the neutron. James Chadwick, 1932. The final piece of the puzzle came with the discovery of the neutron by British physicist James Chadwick. The neutron, an uncharged particle found in the nucleus, accounted for the remaining atomic mass not explained by protons alone. Chadwick's discovery helped refine the atomic model and provided a deeper understanding of nuclear reactions, such as fission. Conclusion: the atomic model has evolved from the indivisible atomos of the ancient Greeks to a complex quantum mechanical model where particles exhibit both wave-like and particle-like behaviors. Each breakthrough has brought us closer to understanding the fundamental nature of matter, shaping the modern atomic theory used today in chemistry and physics. Thanks for watching this video. Before we are ending the video, please make sure to like, share, and subscribe our channel. See you in the next video.